Okay, continuing on. From an airplane at an altitude of 1,500 meters, the angle of depression to a building on the ground measures 28 degrees. Find the distance from the plane to the building. So here we have our airplane, and he's got an altitude of 1,500 feet, and altitude is where the airplane is, straight down to the ground, perpendicular. And the angle of depression. So from the airplane's point of view, here's my horizontal line of sight, and he's looking down at the building at 28 degrees. Angle of depression is looking down. And then I complete my triangle, and they want to find out the distance from the plane to the building. So that would be my horizontal distance. Now, if you'll remember, this angle, horizontal line of sight of the airplane and this horizontal distance that we need to find are parallel, which means if the angle of depression is 28, then the alternate interior angle here is also 28. So that gives us our theta, which makes 1,500 our opposite side, and it makes x our adjacent side. So again, if I write SOHCAHTOA, to help me remember which trig function to use, I need opposite and adjacent. Opposite and adjacent is the tangent function. So I'm going to write the tangent of 28 degrees is equal to opposite 1,500 over adjacent x. And again, what we should notice if x is in the denominator, that when I solve for x, these two really just switch places. So x is going to equal 1,500 over the tangent of 28. And I'm going to grab my calculator. Make sure it's still in degree mode, and it is. And I'm type in 1,500 divided by tangent of 28. That means the horizontal distance between the two buildings is 2,821 feet. Okay. Number 10. From a point on the ground, 15 feet from the base of a flagpole, the angle of elevation to the top of the pole measures 53 degrees. How tall is the flagpole? Okay, so from the point on the ground to the flagpole is 15 feet, and I want to know the length of the flagpole. Okay, well that makes 53 my angle, so that's my theta. That makes x my opposite side. That makes 15 my adjacent side. And again, I'm going to be using the tangent function since that works with opposite over adjacent. So I have tangent of 53 equals opposite x over adjacent 15. This time I'm going to have to put the tangent over 1, and I'm going to cross multiply. So I get 15 tangent of 53 is equal to x. And getting my calculator back over, I'm going to type in 15 tangent of 53, and that gives me the length of the flagpole is 19.9 feet. And that's the length of the flagpole. In just a moment, I'm going to move it up to get the objective 3, blast from the past. Okay, so this covers the special segments from Unit 7. We had the perpendicular bisectors, angle bisectors, medians, and altitudes. And that gave us the circumcenter, incenter, median. No, medians was the centroid, and then we had the orthocenter. Okay, Well, based on this information here, this is an angle bisector because it's splitting the angle into two congruent pieces. One of the properties of the angle bisector was any point along the angle bisector, such as x, is equidistant to the side. So that means 3h plus 5 and 7h minus 5 are equal distance away. So that helps us set up an equation. 7h minus 5 is equal to the 3h plus 5. Those are equivalent to one another. So that means I can solve for h. So I'm going to subtract 3h from both sides because I do want to collect all my h's on one side. That gives me 4h minus 5 equals 5. Then I want to move the negative 5, so I do the opposite by adding 5. And 4h is equal to 10. Then I divide by 4, and I get h is equal to 5 over 2 when it reduces, or I could use 2.5, the decimal representation. Okay, now if you remember on the test, a lot of you stopped here because you didn't answer the question. What is the length of xy? xy is 7h minus 5. So xy is 7h minus 5. Well, I found h. H is 2.5, so I can plug that in. 7 times 2.5 minus 5, and since we have our calculator up and handy, I'm going to type in 7 times 2.5, and then I'm going to subtract 5, and I get 12.5. So that answer choice is there. XY is 12.5, and that's going to be B. Okay, I'm going to have to move it up for a moment to get number 2. Okay, number 2, what type of special segment is CI? Well, I see CI is this segment right here. So what I'm looking at is I'm looking at these markings right here, and it looks to be like I am splitting that angle in half. If I'm splitting that angle in half, then it makes it an angle bisector. Okay, I'm going to move it again. Okay, number 3, what is the length of RO? What I'm noticing here is that RO goes from here to here, and it looks to me like it's a median because I don't see any angle markings like the other 2 examples, and I don't see any perpendicular lines, which is what's required of the perpendicular bisector, and the altitude. So this is a median, which means it goes from this vertex to the midpoint on the opposite side. Now, the special property about the medians is that the centroid, which is point L, and O, which is the vertex, that is 2/3 of the distance of the entire segment. Okay, so what that means is LO would be 2/3 the distance of the entire segment RO. Okay, and with that, with fractions, if this is 2/3 of the length, then that means RL is 1/3 of the length because I have to have 3/3 to make a whole. So I know that 10 is 1/3 of the length of RO. If I need the whole length, then I need all 3 parts. So explaining it fraction-wise, if I have 10 and that's 1/3, another 10, that would be another 1/3, and here's another 10, that would be another 1/3. That would make a whole because now I would have 3/3, which is 1, which means if I have 10, 10, and 10, that means the length of the entire segment is 30. Okay, here is your preview. Your test is coming up. Good luck.